All right, so here are practice problems. We're gonna do a couple together, and then you are gonna finish up the rest and check your work with the answer key that is posted with this. So a couple things that we have to do here. We have our checklist that we have to go through. So we have to figure out our conjugate pairs. We have to figure out which reactant gains a proton and which reactant donates or gives away the proton. And remember, whenever we say proton, that is the same thing as a hydrogen ion, okay? As a hydrogen going from one thing to the other. And just remember, that's the only thing happening here, that there is one hydrogen ion leaving one reactant and going to the other. That's the only change that's happening in this reaction. All right, so we have to figure out our pairs. Then we have to figure out who is donating or who donates and who accepts the proton. And I'm just going to put H plus because that's easier to write. Okay, and remember that whoever donates the H plus is the acid. Whoever accepts the H plus, that is your base. Okay? So that is just a quick review of the notes that was just in the video. All right, so let's take a look at number one. I have HCl and I have H2O. So I need to find something on the product side that is the conjugate pair to the HCl. So I need to find something that has one more or one less hydrogen than HCl, because again, it's either donating or accepting. Same thing with H2O. I have to find something that has 3 hydrogens or 1 hydrogen with an oxygen. So the HCl, I take a look at my products. Well, I have an oxygen here. This does not have an oxygen, so I'm going to get rid of that as a choice right away and take a look at this one. So we are definitely different by 1 hydrogen here. So my first conjugate pair is going to be the HCl and the Cl negative. So that means that these should be different by 1 hydrogen, which they are. So I'm going to pair them off. Now I have to figure out who is my acid and who is my base. So who is donating a hydrogen ion? Who is giving a hydrogen away, all right, or losing a hydrogen? So I have HCl turning into Cl. I have H2O turning into H3O. Well, the HCl turns into Cl by donating or giving away a hydrogen. So this is going to be my Bronsted-Lowry acid. The H2O is going to be the Bronsted-Lowry base because it turns into H3O, so that means it accepts that hydrogen. So the hydrogen ion leaves the HCl and goes to the H2O. For number 2, I got H2S plus water, and I end up with HS negative plus H3O positive. So this one, we have a sulfur here right away. I'm going to kind of hone in on the sulfur because nothing else, these don't have sulfur atoms in them. So I'm going to look at those hydrogens to see if they're different by 1 hydrogen. Well, I got 2 here and I got 1 here. I got 1 sulfur for each one, so that is definitely a conjugate pair. Okay, so that H2S turned into HS. So I got H2O and I got H3O, so we're good. That is our other pair. And if you've noticed, you're going to see a lot of water in these reactions between hydrogen, hydroxide, and hydronium. So you're going to see those conjugate pairs, dealing with the H2O molecule. All right, so H2S turns into HS. It does that by losing or donating or getting rid of 1 hydrogen. So again, since this is getting rid of or donating the hydrogen, that will be our Bronsted-Lowry acid. The H2O turns into H3O. So since it goes from 2 hydrogens to 3, that means the H2O gained a hydrogen ion. And if you gain or accept that hydrogen ion from something else, that is your Bronsted-Lowry base. All right, and we'll take a look at one more. We'll do number 3 together. So number 3, I have phosphate. I have PO4 with a -3 charge, and that is reacting with a molecule of HF, and we end up with HPO4 with a -2 charge plus a fluoride ion. So let's take a look at our reactants and our products. Well, right here, very simple. I got HF and I got F. So those two are different by 1 hydrogen. And in fact, that HF just got rid of the H and turned into F with a -1 charge. So when I take a look at the other molecules, the PO4 and the HPO4, does not have a hydrogen, has a hydrogen. Definitely the other conjugate pair. All right, so who is the acid and who is the base? Well, we said before that HF gets rid of its H to turn into F -1. So if this is getting rid of a hydrogen, it's donating the hydrogen. That would be our Bronsted-Lowry acid. And PO4 turns into HPO4, so that hydrogen that got lost here had to have been accepted or gained by the PO4, which makes it our base. And that's our Bronsted-Lowry base. All right, so your job now is to complete the rest of these questions. You have 4 through 10. I do have the answer key posted. So go through, give yourself a few minutes, complete your work, check your answers, and if you have any questions, please let me know. Starting on Monday, you'll be reviewing the properties of acids and bases and the Arrhenius and the Bronsted-Lowry theory. So you'll have a little bit more practice to do with those first 3 pages of notes. Okay, guys, have a great day. Talk to you soon.